Hello everyone, welcome to today's video cast on the importance of hoof pastern axis and phalangeal alignment. I'm Yogi Sharp, the equine documentalist, and I'm very excited to have two people I admire and have been mentoring me a bit. Dr. Tuki Myers is a veterinarian and farrier focused on difficult hoof pathology and practices, predominantly in Virginia and Centerville, USA. He has an extensive bio, far too long to mention his numerous achievements. But if you want to know more about both Dr. Myers and Sylvia Corner, you can visit their website, hoovesandhorses.com, as you can see in the bottom right hand of the screen, and peruse their team profile. Sylvia Corner is an equine podiatry technologist and equine nutritionist focused on metabolic horses, who mentored under Dr. Myers, and together with Dr. Myers' partners Carleen, a formidable trainer and trimmer, the trio formed EPC Solutions as an extension of their individual businesses, catering to international consultants and educational programs with a vision to offer advanced podiatry care that would otherwise not be affordable or accessible to the average individual or to countries that do not have easy access to knowledge, protocol and skill sets for difficult hoof pathology management. So,
thanks so much, Yogi. And we really want to start off by thanking you for inviting us here on the video talk today. This is a subject very dear to our hearts. It's basically the fundamental guideline we use and we build around to sustain our hoof health and maintenance year round. And we're just hoping that this is a great opportunity if folks listening in could consider why we're having this conversation. And just exactly why do we feel this is such an important topic to share? So, you know, after all, bony column is just one piece of the puzzle, right? There's multitude factors involved in foot health, but you know, basically, unless we start to break it down and look at each piece, it's very easy to bury jewels of enlightenment hidden amongst, you know, the treasure chest of understanding. So that's my philosophy. You know, if you ever have a chance to sit down with an orthopedic surgeon, I highly recommend it. They can really unwrap how joint stress, shear, leverage, soft tissue injury, how it all correlates with the fundamental alignment of the bony column. And we very quickly start to extrapolate how intricate the implications are when we fail to address those bone orientations. So, you know, we're very fortunate. We're able to work on a wide variety of horse feet, of breeds, of disciplines, and different workloads, and access with a lot of good diagnostic tools. So, you know, we're blessed because when you see enough cases, eventually you do see a direct correlation between bony alignment and long-term soundness. So having said that, nothing of course happens in a vacuum. There are like multiple factors at play at any given time along the farrier cycle, but we really don't have time to be touching much on, say, medial lateral imbalance or even conformational defects in this video. And of course, we realize that's another very important piece of the puzzle. But for today, we would really like to consider your attention to this really important aspect, which we call bony column alignment, and what that ultimately means to the horse.
perfect, exactly. So today, on bone column alignment, as you just said. To start with, we should probably outline what hoof pastern axis is and what bone column alignment is. So Tuki, perhaps you'd like to go through each of those for us and explain the difference.
Sure, I can do that. Thank you. The hoof pastern axis is assessed on the individual horse looking at the exterior dorsal hoof wall angle in relation to the pastern angle. Now, ideally, the assessed slope or angle of the dorsal wall should align with the angle of the pastern. This observation best done on a flat surface with the cannon bone vertical. You can use a straight marker. A rasp works really well. And you set it alongside the pastern, tilting it to mirror the angle of the pastern. And then you just simply sort of do a soft eyes, back up a little bit, and take a look at that rasp. Now, does this include the foot in front of the rasp, and look at the heel and dorsal wall? These all should match. The P2 orientation is not visible externally, and so it's not factored into the equation. Pastern angle and dorsal wall angle combined demonstrate the hoof pastern axis. The two assessments should match or form a straight line or parallel ones. When you get to bony column alignment, that's assessed radiographically, and we also want to assess it with the cannon bone perpendicular or vertical to the ground, with the horse adopting a resting stance position with 4 equally loaded limbs. This is to give us a standard that we can get the same measurements repeatedly rather than trying to calculate whether the horse is standing camped under or camped out, which is going to also affect the view of the bony column alignment. So our first phalanx, P1, second phalanx, or P2, and the third, P3, should align in a straight line to one another and to the hoof capsule positioned in such a manner that the load bearing is optimally distributed and no undue stress on any one area of the distal limb. We're trying to equalize all of your extensor and flexor forces at rest. A true bony column alignment with a distal limb balance assessment can only be determined using accurate lateral radiographs. This brings to light the necessity of having a good working relationship between the owner, farrier, and veterinarian. Deviations of straight line orientation of either the HPA or the bony column alignment are defined as broken back, where the hoof slope is lower than the pastern slope, or broken forward, where the hoof slope is higher than the pastern slope. From here, we can move on into some differences and similarities between these concepts and how to use them to work with the locomotor optimization of our horse.
So something that I've noticed is just how different the hoof pastern axis can be from the phalangeal alignment. I think you're going to explain that a bit more later, but for me, like you said, it really highlights just how important radiographs are for us farriers, and I certainly wish they came more regularly. You mentioned the P2 not being involved in hoof pastern axis. Is that the main reason why we have a difference between the two, or why are the reasons we have a difference between hoof pastern axis and phalangeal alignment?
Yes. You know, like this image is summarizing what we just discussed, with the blue line being the HPA assessment, and you can see it basically ducks around P2. And what we're doing is it'll depict the degree of distal limb alignment with the 3 bones, the P1, 2, and 3, and definitive coffin joint and pastern joint deviances. Both are useful, the HPA and the bony column alignment, when we're understanding the differences. With the use of radiographs, we just get a more comprehensive understanding of phalangeal orientation. Many more soft and hard tissue parameters can also be assessed. We just get to see things in there that might surprise us sometimes in horses that are essentially sound.
Yeah.
When you're doing externally, the main thing that you can see is P1. You can even palpate it to see where the bone is within the soft tissue structures. And then, of course, the hoof capsule, which is surrounding the coffin bone. So there's a lot that can be missed if you just decide, I'm never going to take a radiograph. And I even have had veterinarians say, well, I don't know why you want a radiograph of a sound horse. I said, well, so that when he's unsound, you'll know the changes between the two and you can fix it.
Yeah, absolutely. And I think we're so used to seeing misaligned bone columns that I think we forget what the ideal should actually look like. Now, unfortunately, I very rarely get to see a perfectly aligned radiograph, but you guys have a couple that are close here. Could you talk us through what is the ideal bone column alignment and where do we measure the corresponding angles of the bones from?
Well, our first step, and once we get everything lined up and we've got a good radiograph where everything is straight through joints, straight across the bottom of the coffin bone, and we just assess the general alignment from a viewpoint, then we put it through the Metron program, and we get the actual axes of each individual bone. What we want to do is, as those axes kind of start to overlap, we would like all those little angles between them to come to 0, which would then equal a perfectly aligned bony column. Now, that's obviously a moment in time, some little shifts of the horse's weight if he decides all of a sudden to turn his head a little bit and look at you, then that leg's going to drop. But once he gets equally loaded, they should line up nicely. It helps you a little bit more precise assessment of what you want to do with it. If there's more of a broken back pastern axis, that's going to tell you something about what's going on a little higher. We sometimes are looking at perhaps a digital cushion that's not in really good shape, or even possibly a problem with the horse. I see a lot of them in horses between their like 3-year-olds and 10-year-olds. And some of these are thoroughbreds. And I do see a lot of thoroughbreds with broken back pastern axes. And I feel that it's confirmation, but I think a lot of it has to do with nutrition and bringing them up and then working them pretty hard when they're young. They also have a little bit of to do with that sort of thing. So there's all kinds of different things that you're working with when you're doing x-rays.
Yeah, I mean, absolutely. I mean, most of the horses I see are thoroughbreds, and 99% of them have got broken back hoof pastern axis. And I spoke a little bit about that with Derek Popard in my last video about the reasons for that. Rotations. Can you just explain to us where we're taking the measurement for each angle for each bone from?
Well, your navicular angle, you can see that with the big long arrow sweep. We use the sort of the distal portion of the navicular bone where it receives the most contact with the deep distal flexor tendon, which we'll be covering later. And we like that. We would prefer that angle to be about 40 degrees or better in most horses. That seems to maintain soundness on a pretty even level. We don't see, unless there's some other pathology in other joints, a navicular angle that's that high is usually not going to be a problem within this horse, and he should be sound. The pastern joint angle we measure, you can see the little X at the end of P1, and we will run a line through this right in the center of the bone. You can see the tip of that green line as it's highest point, and that's right in the middle of the bone. And then the second point of that line will go through that X, and then we extend it out somewhat so that we can catch the same axis as we go through P2 in an attempt to link those up into a nice zero angle between each one of those. And the same with the coffin bone.
One thing I'd like to point out, because many of us are dealing with radiographs, not necessarily with a team vet and farrier, and we're not familiar with the history, and some of the protocols are very different. So one thing that will change your bony alignment when you're trying to assess an x-ray is the vertical position of the cannon bone. And many x-rays are cut off. Maybe the cassette is too small, the horse is too big, and you don't see at least a distal portion of that. And without assessing whether you have a vertical cannon bone can make a huge difference in how you analyze that radiograph. For example, these horses with negative PAs, extremely broken back bony columns, are extremely uncomfortable, and they find that they're more comfortable when they actually camp or throw their leg and limb under their center of their body. And it actually aligns their phalanges more so than it really truly in reality is. So if you were to straighten that hind limb with a vertical cannon bone, you would find a much more drastically broken back configuration. So these are kind of things you have to think about when you're working with a team that maybe is not giving you the full information. And a very good thing to do is to ask for photos. The owners are often on site, and you ask them to take a full body photo as the x-rays are being done, because it can tell us so much information, like Dr. Myers alluded to. You could have a change in posture, you could have a change in loading without directly thinking about it. You could have a fetlock drop, which changes your bone and column alignment. So having photos are also extremely useful alongside with the radiograph protocol.
Yeah, definitely. And also the positioning of the foot on the block, like if you adduct the leg, or you bring it forward or backwards, like you said, having that vertical metatarsal is really important.
So well, one tip I can throw out there is I use a 10 by 12 plate. I don't use an 8 by 10. And right. That way I can catch most horses. Now there's a few drafts and a few really big guys that you have a hard time catching their cannon bone.
Yeah. Well, like I said before, most of my referrals are thoroughbreds. But for me, nearly every single horse that comes to me from veterinary referral, they're asking me to create more optimal balance around the center of rotation, not just dorsopalmar medial lateral balance, but bone column alignment too. And I have found this has a profound effect on the posture of the horse as well, as you can see in the right-hand corner. Tuki, I know you had some quick initial thoughts on that subject.
It's kind of one of the first things I want to shoot for, is to wind up, I get this collage here is very similar to everything that I see walking across my door.
Yeah.
They'll be blaming it on anything possible, and we find that a lot of it's nutrition. They kind of forgot about that.
Yeah, yeah.
And I did, as soon as I see them, the first thing I want to do is try and correct that broken back alignment. If I can get even a little bit of ahead of it, so that it's just starting to look better. I have always finding the horses just already feel better. They move better.
Yeah.
And if they have real bad hoof capsules, they also throw their shoes off. But if you turn them out in a large pasture, because they'll move more than they ever did in a long time.
Yeah, absolutely.
So true.
So now we're going to have a look at some of the advantages of having a straight bony alignment. So, Tuki, first of all, you were going to talk to us about stance hoof travel.
Yeah, as we can, this is the typical pattern of the stance phase all the way through liftoff, as the horse, hits the ground, comes to a stop, starts to roll over, and then take off out of there into the flight phase. The trick with that, and we would probably love to do it, is to be able to follow everything that happens on some of these horses and then translate it with horses that are lame and horses that are sound, so that you can figure out what parts that you can fix. But that right now we are getting some of that digital technology, but we're just not quite there yet. So it's just my feeling, and it has been working quite well, is that center phase where we've got the lines there, as things are unraveling to a sort of balanced stance in the center of this stance phase of the whole stride, as opposed to flight, that's a good spot to start. Can recreate leg in the center, standing quietly, equal-loaded, and then let's fix everything that we can with that. And from what I've seen clinically, it translates back out when they start to move.
Yeah. So obviously talking about the effects on the stride, Sylvia, I know you had some comments to make on the Clayton studies.
Yeah, there's been varying, every study you look at, you can have, there are studies in agreement and in opposition, but we found that this study was quite closely related to our observations in the field, where Clayton basically tried to recreate a very low acute angled hoof angle, a very low angle. So she reduced an average, and the average was within a 10 degrees range of what we call average. Doesn't mean it's normal, but it's average. And she further reduced it by 10 degrees. And what she found was these horses now changed their gait, and she found it predominantly Tophers Landing at the trot. We see this very commonly when the lower the PA drops, in other words, the more broken back your bony column alignment becomes. We absolutely do see a correlation with not even a flat landing, but actually a Tophers landing at the walk and trot, and even at the canter. And again, we have to ask ourselves, what does this mean, and what does this imply long-term for the internal structures? So Tophers landing occasionally is one thing, but when you put a horse into a situation now where biomechanically it's really all he can do consistently, we have to see what kind of damage we're creating. And we have found a direct correlation with bony column alignment. If it is malaligned, you start moving towards a Tophers landing. So I think also there was some discussion in that study about stride, which was quite interesting. I'm going to actually probably quote her, because she found that not what we would expect. She found the interesting finding that in horses that were moving at constant velocity, that the stride length was not increased significantly. In other words, not what the industry proposes for performance. quite the opposite. And as a result, she found that the prolonged breakover time on these very low hoof angled cases actually reduced the ability to increase your stride frequency, which, in my opinion, would be a negative impact on any of the speed disciplines.
Yeah, because there's studies that have shown that horses have a preferred stride length, don't they? So in order to speed up, to increase their frequency, so that would obviously hinder their ability to do that.
Yeah, certainly according to her study, and I tend to migrate toward that.
Yeah. So the biomechanical efficiency obviously plays a role on the strains of all the structures of the digit, as you just said. The ligaments being one of those. Now, Tuki, I know you have some slides to talk about on the relationship between bony alignment and the ligaments.
You look at the straight sesamoidean that you have in your legend on the right. You can see that behind the pastern bone, and there are some other oblique sesamoidean ligaments back there. So this next slide, bring that one up. These are not thought of very much, but this horse has lesions in those oblique sesamoidean ligaments, and they're showing up there where those arrows are. So we don't really know we know there's obviously inflammation back there. We've not even a lot of times gone into just trying to selectively block that area. That's difficult because the lidocaine or carbocaine will seep near the nerves and start blocking the foot out too. But at any rate, they're not even looked at, and I think there's a lot more significance in some of these smaller ligaments than what we realize. This one has obviously gone on long enough to cause bony changes.
Yeah, in fact, if you looked at Parker 1973 studies, he also noted the exact same thing that Dr. Myers is bringing up, talking about sesamoid ligament pathology, especially in the latter part of the stance phase. So something to consider.
Definitely. And then you had some comments to make on the suspensory ligament of the navicular bone.
One you run into is as you're increasing that breakover and sort of nailing that foot down for a while, and you're increasing the stress on that suspensory ligament of the navicular bone. It's just increasing more and more as this horse is trying to get this toe off the ground before that lifts, that is not going to let up. So now it's stretching further, and also maintaining that stretch for even milliseconds makes a difference, because I don't know how many strides a horse normally takes in a mile, but it's going to be a lot. And when he does it every week, it's going to do a lot of damage.
Yeah.
That impacts the impar ligament, that impacts the deep digital flexor tendon, actually putting more pressure against that navicular bone and pushing it into the joint space, which you've got some depictions a little bit later on in the slide presentation as well.
Yeah, and as you're saying, if they're having this cycle after cycle after cycle, then that can then of course lead to long-term pathology. You've got.
Okay, this is cycle after cycle after cycle. This horse is 20 years old.
Yeah.
I finally saw him as he was very aged, and I was told that he was diagnosed with navicular disease and he was treated with phenylbutazone and bar shoes. Obviously not terribly successfully. I had trimmed him. His feet were probably, those toes were sticking out a good 2 inches further than what you're seeing now. And that was kind of one of his initial trims, just to try to help him out. His legs are up in the air because he's holding himself up with his hind legs. When you would turn him, he'd rock back like a reining horse and turn.
Wow.
He looked laminitic, and yet, you don't see a whole lot of distance there. And he's not really sinking at all. I mean, that extensor process is right up there and tight, but his heels are horrible. That to the left-hand photo, right above that navicular bone, it would be near that bony growth is likely the attachment of the suspensory ligament into the wing of the navicular bone.
Right. So this is what we expect to see if, long-term misalignment, basically.
Oh yeah, he's got the joint capsule too in the left one. You notice both these joint capsules are pretty prominent in that coffin joint, which we don't usually see. Now, either it's because he's lifting his weight off of them, or they're likely inflamed and just swollen with inflammatory fluids.
So just to introduce your next subject on misalignment, I wanted to just talk a little bit about this slide. So the distal phalanx, as you can see in this picture, is suspended within the hoof capsule by its attachment to the dorsal wall via the suspensory apparatus of the distal phalanx. The distal phalanx is encapsulated in sensitive laminae, which interdigitate with the horny laminae. This suspensory apparatus of the distal phalanx plays a role in absorbing and redirecting the forces of impact. So some of the compressive forces up the dorsal wall, which you can see the red arrow, is transferred into tensile forces through the laminal bond. Now, if we take a closer look at the suspensory apparatus of the distal phalanx and this interdigitation, which has been beautifully shown here by Polly and French, this interlocking of the wall and bone through these leaves is what keeps the bone in place. Quickly, you have some comments to make on how bony alignment can actually affect.
These three x-rays are very self-explanatory, and when you're dealing with metabolic horses in particular, you'll see it an awful lot of cases where you have an interesting case of broken back alignment, and then they develop laminitis. So depending on how much of that structure remains in integrity to the hoof wall via the lamina, depends on whether you get rotation, whether you get sinking. There's so many, this is such a vast, complex subject when laminitis is brought on into as an additional secondary source on top of your broken alignment. From a vet perspective, maybe, Tookie, you could take it a little further in what you're seeing.
Yeah, for this one, the one thing I'd make is a general commentary on the working of the laminae and aligning the bony column. One of the things that the laminae are taxed with is not just holding the bone in a proper position within the hoof capsule, but they also are one of your first lines of shock dissipation. As soon as the slide is done with and the thing gets its full impact hitting the ground, then the laminae, because of the complex structure, not only just dampen it coming up the foot, they do so by actually redirecting some of the forces laterally and circular fashion to try to dampen them further before they start going up the leg, which they still will. So the laminae have a lot of work to do in the movement of the horse. This particular horse too shows you a lot of things that radiographs are good for. If you were to, you could visualize this horse's foot very easily and would say, well, yes, he's been foundered. There's no two ways about it. There's no doubt about it. But you can't tell quite how badly. He obviously, once he was laminae partially released, he aligned his bony column for everybody. And that was nice of him. And then they rockered the toe. But as you see, he has dropped down in the hoof capsules because he's lost a lot of laminar attachments and he's compressing the sole. There's even a little notch at the angled arrow second from the bottom, and that shows where his coffin, the tip of that coffin bone likely was before it rotated, and then he straightened out his pastern axis and tried to start growing a foot with not a whole lot to do it with.
This is also a great example to show you where we didn't have perfect protocol, probably a very uncomfortable horse, but if you look at that cannon bone, it's not vertical to the ground. So in essence, if you were to straighten that vertical cannon bone, you're going to change that bony alignment. So that's not a true depiction, but it still gives you a very good idea. You can extrapolate from that.
Yeah. Something I often in malaligned radiographs is uneven joint spaces, which possibly predisposes to arthritic changes. Also, you explained in the Clayton study, these horses would be more prone to Tophers landings, and that can also create arthritic issues. So, for instance, in this one, we can see that there's a joint space pinching cranially at P2 and P3 and caudally at P1, P2. But I think that's quite often different, isn't it?
Yeah, the main pinching that I see and the lesions that result seem to be on the cranial aspect, particularly in the early stages. I see a lot of high ring bone, particularly if these big warm bloods have relatively upright pasterns, and they tend to want a little bit more foot on them, and I wish they wouldn't do that. But it will make the horse lift his knees more. Why they decided they wanted dressage horses to lift their knees. It does look pretty, but that's all it's for. And I'm a saddlebred man. I like them to lift their knees.
Yeah, this
Yeah.
is an interesting slide
Yeah.
regarding how that P2 is slightly sagging.
What happens, again, we're not really sure why, and there's probably a number of reasons. But that's going to be possibly some of your smaller suspensory ligaments, possibly some of the other ligaments around that joint capsule, even the superficial flexor tendon may have some problems at that spot as it comes around the back of the fetlock and inserts down there. Again, I ascribe it to the possibilities of poor nutrition because they tend to feed thoroughbreds a lot of pretty high carbohydrate diets. What happens with these guys, if you have to pick, when we're measuring bone angles, oh my God, is that aligned or is it broken forward? Is it broken backwards? And we pick out P1 and we pick out P3. And if you were to pull those together, that's pretty good alignment. And we would go with that because mechanically, that's what he's going to be functioning around. There's not much, there's only 12 to 15 degrees of motion in a pastern joint. So we like it aligned, but if we can get P1 and P3, we'll go for that. And we're not too worried about P2 unless it's way out of alignment.
Yeah, this is something that I see quite often actually in race.
Yeah, if you're doing thoroughbreds, yeah, you do.
Yeah.
And then, there's a possibility we don't have all the answers, but a lot of these horses with broken alignment, if you look at the displacement of the heel, it's forward. It's
Yeah.
closer under the navicular bone. And so you're prolapsing or you're sagging soft tissue, digital cushion, collateral cartilage. And guess what? They're all through ligaments attached to the bone as well. So,
Yeah.
If you don't have proper positioning and you don't have good caudal support with your heel location, we will find quite often once we do have caudal heel location corrected, all of a sudden what looks like a poor digital cushion quality on an x-ray plumps up. And in that in itself will help orientate support the internal structures of P2 as well.
Because that bone, the P2, your pastern joint is not really going to move very much. It's kind of set in its ways, I guess. What will happen is if you manage to lift it up and line it up, that's great. If you don't, that doesn't seem to be a big problem for a horse as long as he's not putting a cranial pressure as he's moving over that joint. He will some, but that you'll have to actually break him back. If you decided to align the coffin bone with P2, then you could create high ring bone. So there's a problem for you there.
Right.
Exactly.
Keeping him like he is, you're going to be okay. If you decide, oh no, I want him aligned with P2 and P3, well, now you really are going to start stressing that P1, P2 joint.
Right. So in terms of joint spacing, which is what I introduced this slide with, is if you were to try and realign that P3 then with the P2, you're then going to affect joint spacing. Is that?
Oh yeah, you will. And you figure that now you're going to put some leverage right there using the P1, P2 as a fulcrum. Whereas right now it's going to kind of balance itself out.
Right. And as a caveat, when you're first learning bone and column alignment, as a farrier, you don't have the insight as many vets do, right? So you may look at that and say, well, actually what I have is a broken forward configuration.
Yeah, and it's
very confusing. So I always, when we have our education programs, we always teach to look at P1 in relation to P3 before you jump to the conclusions.
And then here with HPA, if you take the bones out and pretend that's just a nice gray silhouette, that's going to be aligned pretty well from visual standpoint.
Yeah. So some more on malalignment issues.
So we have another example here of Tophers Landing with some other effects that go along with it. And there are many more than the original navicular one we talked about. Now we've got another one. When this foot comes to a halt and it's stopping very quickly on the toe and much faster than it should, when it hits a heel first landing, it'll slide more gracefully to a stop, remove a lot of the vibration and allow the horse to sort of settle into his stride. With this, we're going to stick his toe in the ground. He's going to break a lot faster. Well, when he breaks a lot faster here, as we saw with the pull that's started to pull on the navicular bone, it gets even worse as the stopping kind of the coffin bone is pushing forward and pushing up. And as it steps down from the top, it rolls P2 backward along the slope of the coffin joint and back into the navicular bone. So that is, and then in turn, you're stretching all those ligaments even further before you've even reached, now they're tightened before we've even reached that point where the horse is trying to break over. So this spornavicular bone is tortured all the way through the stride. When we're looking at malalignment, and this is an old pasture pet horse. They used to trail ride him years ago, and they kind of had the farrier out whenever they could get one to wander by, partly because of this horse, because he was always such a pill to try to trim. So in the process, they just, as you can see, that big long toe, that was before and after the trim, by the way. And I hadn't seen him for years, and go out there and they said, well, we can't get a farrier out. And of course, when I tried to start messing with his feet, I found out why. So he had to be sedated for all this work. And he's developed some serious high ring bone. He's starting on some low ring bone. You can see a few little spurs kind of popping around right in the front of that P2 joint. And that's going to be part of the joint capsule attachment is messing up there. And this guy just can't move that joint at all. And the trick is, too, with these horses, once that joint starts to fuse, you do have to be a little bit careful on trying to overdo the alignment. Once you see where we got him flat and he's still at a negative palmar angle, that joint hasn't budged. And if I try to stand him up, he will be a very unhappy camper. Again, also him trying to compensate with the left picture, you can see the cannon bone tilted back. Because that's the only, even with sedation, that's the only way we could get him to stay on the block. And he wasn't making it easy.
With cases like this, when you have a broken alignment long term, you have a lot of inflammation where there's cranial pinching. In that case,
oh yeah,
right at P1 and P2. So imagine then with a broken bony column, you have a horse that's uncomfortable and then lands toe first. Now, where did the vibrational forces go? Right up the bone. So
yeah.
You have a double whammy in these situations. So my question is, though, on this particular one, can you, we still have a good articulating surface at the coffin joint. Are you able to manipulate somewhat more so that you can perhaps increase the PA?
You could let him do it. The next step I would take, probably, I wouldn't try to put any wedges or anything on him to start with. I would just put like a light roller and see what he wants to do with it. And maybe give him some time with it to work it out, and let his hoof start changing, with him, and just proceed carefully. Because I like just a roller and maybe a shock absorption pad, just to help that out too, because he still can't land right, and we can dissipate some of the shock through any type of materials that do actually absorb concussion as the foot hits the ground.
Thank you. That is such important advice. That was a lead-in, just to, for our viewers to listening in. The one time we are very careful and slow to bony column align a foot is when ring bone is involved, particularly if you have fusion.
Or even starting fusion is worse.
Yeah.
Because you're really messing with it. It still can move a little bit. I doubt this one would move much, but he's still not going to work very well trying to lift his heel up a whole lot.
Right.
Right, so as we've seen in a lot of the slides previously, that most of the time misaligned hooves comes down to low run forward heels and the heel to toe height ratio. So when the heels are run forward, as I think one of you mentioned, they get caught in a perpetual cycle. Something that Bowker discussed was about how their position relative to the deeper structures means they're prone to increased shock forces. So if we look at these two radiographs, we can see the malaligned hoof has the heels under the wing of P3. So the concussive forces are being transferred onto the bone, and the heels are in between a rock and a hard place, if you like. And there's going to create some trauma to the structures in that area. And Bowker also talked about affecting the blood supply and nutrition to the area as well. Whereas the right-hand radiograph, the heels are underneath all of the nice squishy hemodynamic structures and the mass of the digital cushion. So the underrun hoof is therefore predisposed to clinical foot problems. Now, I know you guys have some more in-depth comments about this positioning of the heels.
I know that Toki's going to be speaking on a few slides down that are specific to that, I just wanted to point out, if we go back to your original slide there, Yogi, I wanted to point out something some people may not be aware of and might be useful, is Bowker did some really excellent clinical lab studies, and he actually looked at a microscopic level, at the cellular level of these digital cushions. And the good news is he found that it was composed of what's called myxoid tissue. It's a very primitive tissue, and it differentiates. So if you stimulate, put it under load, it changes from more of a fat composition to more of a fibrocartilage. So on these horses, you know, provided some of that microvasculature network that he found around the navicular area, if it's not damaged to the point that you have necrosis, in other words, if you can still recapture some of those blood vessels and start giving nutrient back into these tissues, you can actually have more differentiation continue on with your myxoid tissue. In other words, you can actually improve the quality of your digital cushion, provided you still have blood flow and nutrient delivery to the area and you don't have necrosis. So that's you know, something hopeful to think about.
That's very interesting, because in the discussion that I had with Eric Popard about training young racehorses barefoot, and how both Page Boss and Bowker talked about how possibly the reasons behind thoroughbreds having such inherently weak feet is the fact that they're not allowed to develop from a young age. So they're being put into shoes at such a young age, and then that could possibly be having a destructive effect on the hemodynamic systems. Do you think that that's something that plays a role?
We've seen it on the track, because here in Canada and near Toronto, we have a track that permits barefoot racing. And our rest in peace, our wonderful ex-Purina, shall we say, he was Canadian's formulator for years, but he also had a great breeding program, and he would take on these thoroughbreds that weren't doing well off the track and reinvent the wheel. He'd throw them out to pasture, not something you do with thoroughbreds, with a top-notch feeding high protein diet, not too high enough, because these guys don't get enough protein, and basically rehabbed barefoot. He spent some time with Dr. Myers and myself, and he had a farrier up there who rehabbed them barefoot, and it was amazing within short of 2 weeks how that entire capsule remodeled.
Wow.
And towards the positive, I mean, very robust structures in 2 weeks, because, you know, horses like this are dealing with a lot of force, right? But they're also dealing with training specifically geared to build them up. So if you know what you're doing, it can actually be a positive reinforcement, right? Wolff's Law rather than a negative. And he had some unbelievably good results. His best horse that came in first, unfortunately, got disqualified because he came in without the jockey on him.
he didn't pay enough money for a good jockey. Huh?
Yeah.
Cheapskate.
That leads us on then to this slide.
This goes back to elaborating on your slide before we got into the digital cushion.
This is a diagrammatic representation of what can happen with these negative palmar angles and very run out toes and very underrun heels. With the big force vector, not only is it just rough on the whole deal, it's coming straight through COR and straight through the navicular bone and right on top of near the insertion of the deep flexor tendon as it's rolling under the navicular bone, and as opposed to the horse, and of course completely away from the digital cushion. And now we've got to get the horse aligned and get everything put in place. And now we've got the same force vector coming down. It's going through the digital cushion. It's missing all your sensitive structures that it should miss. And this horse is going to race a little longer, and his speed is going to be up to his training and his breeding. I kind of worked this out, and it's interesting. When you first look at it, it is a lot to look at. And what we want to do is just compare the image to the images as they line up there to that left image as your output load against your input or effort and your fulcrum. So when we're looking at this, the fulcrum in the diagram to the left is actually the COR in the diagram on the right. So the horse in the diagram on the left is the load portion. This is the forces coming down, which are the forces coming down from the horse's mass as he's loading, landing, and slowing down and then getting ready to move forward again. And that is coming straight through the cannon bone and putting a whole lot of force down towards that heel. So it goes along the pastern bone, and now it's coming to our input or effort force, and that's going to be how much area is between, or how length is between the COR and the back of the heel. And when we have more, we are distributing this effort on over a larger area so that each individual little point is not taking so much impact. When we go on the bottom one, now that when we've got that thing tight, so tight that it's just crushing and pinning everything between what a little part of the digital cushion and right up against the bone, it is going to just destroy the digital cushion over time.
So that's to do with the distance, the length of the shoe as well as the
yeah, the shoe, and also the distance of the pastern will have a little to do with it. But unfortunately, that's nothing you can do anything about, other than just realize it's there and figure out some ways to try to get that load a little further back. Perhaps if we had a horse with a longer pastern, we might want to put a rocker toe in it if we can work one in to get load moving back and putting it up underneath the leg a little bit more.
You know, if you look at the bottom right diagram of the actual foot, and you can see how you have that digital cushion with no support beneath it, and you see how small that heel base of support is to center of rotation. Just imagine what that heel length looks like as far as angulation. It's got to be very underrun.
Yeah.
So when you think about horn tubules running in an underrun angle with increased loading pressure, because the shorter that little effort arm is, the more load you are applying. So now you have, not only do you have a very poor aligned heel, it's almost collapsing, you've added additional loading forces to it. So naturally that heel is going to collapse. You know, and it's really unfortunate that the wedge gets blamed for this. So yeah, if you put a wedge where that heel currently is, that wedge won't help dissipate any kind of stress because you have that short effort arm and you have additional loading. But if you were to support that heel base a little bit further, if you lengthen that effort arm, you would reduce some of that load compared to where it is now, and you'd also have a better correction in your heel tubule. It'll be a little more upright, and it'll be able to take those downward compressive forces. And then the wedge actually probably wouldn't be a problem, because we don't seem to have those problems with our wedge shoes. So I thought I'd bring that into light because, unfortunately, wedges get blamed for everything.
Yeah, absolutely. That's definitely what I've seen in my experience as well. As long as I provide enough length to my shoe and put the wedge in the right place, and also making sure I trim out any heel that has already exceeded its elastic modulus, because there's no point in putting a wedge on top of a heel that's already collapsed,
right.
in my opinion. And then moving the base back underneath the horse, and I've never had any problems with wedges crushing heels. If you're looking at that bottom right-hand picture, that's why we see so many prolapse bulbs, isn't it? Bulbs falling over the back of the shoes. And so that brings us nicely onto this picture, which quite clearly shows some bulbs that are pretty much touching the floor and pretty much a non-existent heel. Now, using this picture to explain something about axes. Now, in my opinion, there are 3 axes to consider for phalangeal alignment and balance around the centre. If we change any of those axes, it will affect the other axes. So we can change the length and or the orientation of T, H or A, and it will change the others. The third axis, being the bony alignment, is often what is missed, I think, when people are trying to create better proportions to the foot. So what happens is people often try to shorten T right down or make H really long to try and create more balance. But what's actually needed is that the third axis, being bony alignment, needs to be corrected. And then that obviously has a lot to do with the heel-toe ratio. Would you agree with that?
Yeah, that actually brings us beautifully into the next slide, actually.
So like I was saying, often people try to shorten the length of the toe, it's better alignment, and they try to do this by over-rasping the toe. So if we look at this, we can see just how, if you did that, just weakening the toe if you're removing good, strong weight-bearing structures by going through the layers of the wall.
Well, it is a problem if you compromise the integrity of the laminae, and even if you're doing the insensitive laminae, that's a softer hoof tissue and is more malleable and certainly less supportive than the hoof capsule, the horny wall that goes around there. So you don't want to expose it, and you certainly don't want to hit blood from the front. You've really gone too far, but there are those that have done that. And you really, while on the flip side of that too, I see that people will go the other way. You don't want to invade tissue that's really not designed to handle the outer environment. But then they've come to the point where you shouldn't ever lay a rasp on the outside of the hoof wall, ever. Well, then they leave all the flares on. So you don't want to overdo a flare that's so much it'll compromise the total integrity, unless you have a way to replace it. If you want to cast a hoof, you can remove the flares more severely than you can if you're planning on shoeing one. But you have to remember that when you pull the shoe off and you're getting ready to trim it again, you're going to have to readdress those flares and come right back to them again to keep working them back. So you don't want to be too far in either direction.
Now, your red line, Yogi, depicting the rasp line is pretty significant.
Yeah.
But what we do see is quite often is another, common fairy technique is you'll blunt the toe, which means you are invading the stratum medium at some point. And, it's not our preference, but what it does actually accomplish is it does reduce that toe leverage, which means you're going to have some reduction in your DFT linear forces too. So less compression on the navicular bone. But it's not always optimal to do it that way. There are better ways to do it, or in my opinion, better ways to do it. But I did want to bring that up. It's not, in that case, it's not detrimental as far as it's not destroying the integrity of that hoof capsule. But it doesn't particularly look aesthetic, and I feel that there are other things involved that you could do as well.
Rockering the toe would give you a lot better result because it moved the breakover back even further.
Yeah, I mean, it's something that I practice is, I think there's a difference between rasping the wall into an angle from the top of the wall and then there's beveling off the toe and rolling it back. Stephen Bean studied this for his thesis about dorsal wall rounding, found that it actually made a stronger foot. But it's definitely something that I practice is I will round the bottom of the toe off rather than take the dorsal wall from up.
Right, and as a last point, a lot of times you want to get rid of all these growth rings or depressions. We call them horn tubule collapsing. You just want to have a nice shiny hoof, so you rasp the entire thing right up to the cornet. And that's, in my opinion, not ideal. First of all, you lose important landmarks, in my opinion. And also, what happens is you create an angle, such as your red line, that allows you to believe that you have a higher hoof angle than you truly do. And then you basically ignore the fact that you have a broken bony column. It's a bit deceiving.
Yeah, exactly. So let's move on to this slide. I'm very interested to hear about this slide.
This will take a day. I have to backtrack a little bit before we get into this slide, because this is so dear to my heart, this kind of understanding. If you look at a barefoot hoof itself, the bony alignment in that barefoot hoof directly affects your dorsopalmar balance, how much toe will be ahead of COR and how much heel base will be behind COR of the coffin joint. So that can either increase, it can decrease, it can equalize stressors on both the bones and the soft tissue. So the very nature of the hoof growing out at an angle to the ground, that very nature increases toe leverage over time. So that will correlate to what? It'll correlate to a drop in your PA, which is occurring from what? From the broken back axis of the phalanges as the hoof grows out. The only way to avoid that is if you can somehow create enough friction and wear that equalizes the growth. But it's not something that we have the luxury of in our domesticated horses. So without the horse traveling, sufficient distances over varied terrain or, continually wearing and growing at an equalized rate, generally the toe leverage takes over. We get a long toe. So when we apply a package to a less than ideal trimmed foot, we are locking that foot in. And that horse now cannot adjust the trim. So he can't wear that away. And therefore, what does he adjust? He has to adjust his limb and his body to compensate to make it work. So I think we have to be really mindful of all of these factors. And also, we have to be very mindful of the length of our farrier cycles. Because once we apply a package to a foot that prevents the daily wear of the horn, we will further exacerbate the loss of the optimal biomechanics. We'll increase the leverage forces, the stresses across the hoof as the cycle progresses, just by the very nature that the hoof continues to grow out. So for these reasons, we have to place, in my opinion, a very great emphasis to work towards attaining bony column alignment soon, early in the beginning of each farrier cycle. So that way we can help the phalanges keep relatively aligned within a safe range in between the farrier cycles. And then this way, you mitigate the bone and soft tissue breakdown. And what's really interesting, trimming towards a bony column alignment, it actually encourages us to meet all those healthy parameters we need in the foot. It happens simultaneously. You end up with a healthy toe unrollment position, you get a healthy heel-based position, you have healthy support to the soft tissues in the caudal foot, your joint spaces are open, you have very minimum tendon and ligament strain, your movement arms are very, very short, you have maximal distribution of forces across the whole solar imprint. And you cannot achieve those parameters without aligning the phalanges in the trim. Now, that takes us to this slide. We can do things outside of the trim, right? We can put on a shoe, but ultimately it goes back to what you talked about, your 3 axis planes. Here we have different shoes, different hoof types. I won't go into them, but you can see many of us will say, well, listen, if we set that shoe back, right, we can actually get approximately 50-50 or a great improvement of our dorsopalmar balance, front to back. But does it really change the actual bony alignment? If you look at each one of those cases with the shoe back, it does change your dorsopalmar balance, but does it change your alignment? And that's where your slide came in saying you have 3 axes. If you just play with the long toe and the under end heel, but don't do a trim correction, just simply add on a flat shoe, you won't get too far. If you put in a wedge, you're changing angulation, you may get some improvement. But ultimately, if we don't start looking at all those planes, we can't look at this as just simply a flat diagram. We have to remember that we're looking at dimensional characters of this structure. So it takes trimming first, then applied additional assist through the package or the shoe to attain that bony column alignment.
Absolutely. And can you just talk us through the different positions here of the breakovers?
For each individual foot type?
Yeah.
Yeah, so in your line position, really you just have a bit of a Mustang roll or a roll of your toe, and you've got about 50-50 COR displacement between dorsal and palmar balance, about that. It depends on the conformation of the foot. The horse with a longer, lower sloping pastern, it'll be aligned, but it's conformationally more sloping angle, so of course you'll have more toe percentage. These are guidelines, but everything will agree. All these parameters will agree with each other optimally when you do have alignment. If you look at your long toe under on heel, you have a very under on heel base under the navicular bone up here, and you tend to have toe leverage. It's not a laminitic case, but you do have what we call mechanical laminitis, just the sheer torsion or tension on the lamina. You're separating that white line because that white line is a little weaker than the attachments of the actual lamina. So if you bring if you bring that shoe branch or the toe of the shoe back, you've actually improved your toe enrollment, right? So you will have a little less tension on your DDF pull because your extensor moment has decreased. But what have you done for the alignment? Absolutely nothing. You've helped in the release of the tension, You might have a small increase in improvement in alignment because of that enrollment, but very, very little. So pathology continues. Migrated hoof capsules are very easy. Once you assess them, they're very easy to correct because all you have is excessive hoof growth. And over time, along farrier cycles, if you have a quality horn that doesn't break apart, doesn't flare out, a lot of these horses with straighter quarters tend to retain their hoof capsule quite well. So they'll just grow out, they'll follow the angle of the growth, right? And eventually you will just have to trim them back up and they'll do fine. In this case, if you don't touch that heel, there's nothing wrong with that heel angle. It's following the dorsal wall angle. There's nothing wrong with that angle. Simply you have excess grow out or you have a little excess sole depth under the toe. So you might have to take a little correction. In this case, you're supporting, if you follow that white line here, you have to have enough shoe to support the pillar and it will self-correct. Negative PAs are a little more difficult because now you have total horn tubular collapse, you have a lot of soft tissue failure, you have a lot of inflammation. Even if you try to correct that for that horse's foot right now by placing a 50-50 balance, you could not possibly load the back part of that foot. It's not ready to be loaded. You probably have thrush, you have a very, very thin sole because your bar has been compressed and overlaid and you've got very thin solar production underneath there from the compression. So this whole back part is in agony. So even though you want to load it like that, probably the horse won't be able to. Now, if you align him and take pressure off certain weak structures, you might be able to get him to load properly. But just removing that little bit of toe leverage here will minutely help. But as you can see, it will actually not change the orientation because the solar arch is not congruent. In other words, you have much more sole depth here under the toe, and you have crushed virtually no papilla growing with sole depth occurring at the heel. So unless you do an actual trim or a package that builds to relate to that, simply a flat shoe setback won't help. Laminatics, we won't get into because they're so complex, and these are chronic pictures. You know, acute would look totally different on a first time laminitic, but the point is we don't want to be supporting that lamellar wedge, and that's about the only time setting a shoe back flat, even if you did nothing else, would probably help because you're no longer supporting the lamellar wedge. But that, in my opinion, is substandard to what, you know, everything should be done that we could do that's required to get this back to optimal left.
Going on to this one, so you're saying that we do as much as we can with the trim, obviously, but then we have to move on to mechanical intervention, if you like. So if you want to.
Yeah, so this is just a case where we have enough sole depth that if we actually took a trim from quarter to toe and we left that heel alone, you would get an immediate correction. You can see here these arrows. You would get an immediate correction in alignment just by the natural physics, right? But you know, you can't just do that because a lot of these horses, and we'll talk about proprioception a little bit later, so I'll make this simplified at this point, saying you have to be very careful that when you are doing these alignment quickly is very good because you stop pathology. You're not dealing with fusion, you're not dealing with ring bone, you're not dealing with adhesions, so you can do a quick alignment, but be very careful that that back half is able to take on that added load, which it should have, right? You know, instead of having all of the pressure here, now you're starting to move the pressure back here where the soft tissue can take more of the shock, which is what you want. But are your soft tissues prepared? Because for so long they've been damaged. So you use packages. This is just one where you can't really tell, but this is just a heel buttress. The heels are actually floating off the ground surface or off the pad. And so basically you have to have enough of a frog to be able to take on that extra added force while you relieve other areas. But these are just examples to say, you know, bone and column alignment is the best thing you can do for a horse. There are exceptions because of existing pathology limits, but if there aren't, if they're minor, it's one of the best things you can do. The sooner you do it, the better.
Absolutely. So talking about that, so here's an example of one that I showed. If you look at this, it appears to have a long toe and a low heel. Now it does have a low heel, but the question is does it really have a long toe? So if we look at the green line, which is what I achieved on the bottom X-ray, superimposed onto the top X-ray, by changing the position and elevation of the shoe. If I had rasped that angle in, I would have got blood. Now, if you look at the thickness of the wall at the toe in both feet, it's pretty much the same. There's still plenty of wall thickness in the bottom foot. And then if you look at the base split, the bottom pick is close to 50-50. So it's the third axis, correcting the third axis, what I call the third axis, that shortened the toe and made a better angle, which is, you know, to a certain extent, trigonometry. So this didn't have a long toe that needed rasping right back. It had a low heel and a broken phalangeal alignment that needed realigning. Now, we're going to talk a bit more about more of the purposes of realignment, but by doing this, we also reduced the load on the deep digital flexor tendon. Now, the 2016 study, we can see there, cited a 2010 study stating that each degree in palmar angle reduction equaled an increase of 4% load on the DDFT. And I think Weller has also cited that as well. So the 2010 study stated that the forces applied on the foot are well correlated to the changes in the ratio of heel to toe heights and the angle of the distal phalange. So straight away, that's showing us the importance of phalangeal alignment.
This is a good example, I think, of a very simple solution without having to do anything very complicated. And a horse didn't really need it. I do see some people that'll have a long toe like that, and they're going to knock the front of the hoof wall off, and then they're going to try to figure out a variety of other very exotic things to do to the foot, when a very simple solution is just to align the pastern axis, and you had enough foot that you could just touch the bottom of it a little bit and straighten it out and put everything together, and then a nice roll at the toe, and you've got a lot of pressure off of the heel, and away you go. So, and the roll at the toe also takes, straightens up your axis on the bottom.
Yeah, but what amazes me is how some people are afraid to do this because of what people say about, because this is a wedge. People are afraid to do that with the wedge because of the increased load on the heels.
And the radiograph shows very nicely too that your heel, after you did that, is much rounder than the heel that you got presented with.
The bulb, yes.
Yeah, the bulb of the heel, it puffed right up.
We get into these semantics, which worries me. We talk about, we have increased heel load. But, anatomically, the horse was designed, that limb was designed to take more caudal loading with less vibrational forces through the bones. So what we're saying is, yes, we're increasing the load as it should be.
Yeah.
Yes, absolutely.
I think the majority of those people that are making the complaints of the wedge crushing the heel, their heels have already been so badly crushed, they're not paying any attention to your horn tubules, and they're basically just pushing on the back of the hoof, and the heel's not even holding anything. There's no bar support, there's no heel and no bars too, which is, bars are probably a whole another lecture.
So important as well for that heel integrity.
Yeah, so absolutely, like we said before, in order to put wedges on, you need to make sure that you put them onto a solid base.
Yep.
That can actually take them. So, Sylvia, you've got a case here to talk us through.
Yes, I think, I discussed this the other day. This was a common case we had in South Korea, and it was a warm blood imported from I think it was the Netherlands. And it didn't start off this way, and it was a high-level dressage prospect, or it was a competitor.
Yeah,
sorry.
Competitive.
Yeah, sorry. And I had some beautiful videos of him before he broke down. And in South Korea, they don't have good programs for feed, and they don't have a lot of knowledge, but they have the desire to learn. And so this is why we got together as a wonderful team with a very good veterinarian, a very good farrier, well, two of them actually, and Dr. Myers and myself, we completely revamped this case from nutrition right through to vet care and also through podiatry. And these people have gone on now with their knowledge, and they apply that to other horses and other barns. And so it's a really win-win, and I think maybe Tookie, you would do a service to talk about this at maybe a better farrier vet level than I could.
This horse was presented to us. She was very sore. They were very obvious, obviously aware of that. The radiographs can really show you why. This horse has likely got this pastern a little straighter than it usually is, although if you look all the way to your right, she normally has a pretty upright pastern, and that's just the way she's built. Once we got her turned around, and a lot of it was a trim, we had lots of foot to work with. The heels were crushed and kind of weak, though, and we were in the process of, Sylvia had alluded to the buttress pad, and you can actually see some Equipack CS on the back of the horse's hoof there that we were utilizing as a buttress pad to help support her heels. Once all the trims got underway and she did align rather nicely, that's a lot of heel, but the trick is the way she's built. If you look to the x-ray, the radiograph there, and you look back to the foot to your right, you can imagine now that that coffin bone is lining up rather well with the bony column. It's a 64-degree angle, but for her, that's going to work great.
Some of the old textbooks actually would talk about ranges of angles, and it went everywhere from like 48 to 68. And I know that we talk about anything above 60 as a club foot, but again, we have to be so careful about what is common may not necessarily be normal, and there's always the exception, and we have to use our good common logic, what's working for the horse.
Yeah, and we just got it down to trying to align the bony column as best we can, and that worked out pretty good.
Yeah, so regardless of the fact that it may look like it's very, very upright, bony alignment is the ultimate goal.
See, here's the problem. Many horses with a hoof angle of 64, which mirrors, right? It mirrors the coffin bone. You'd think, oh my goodness, like that P3 tip is just digging into the corium, but it's not, because it's not laminitic. So when you have good suspensory apparatus and everything is suspended well in this sling inside the internal hoof capsule, right? You do not have solar compression. That's the big missing fundamental thing we miss. You don't have solar compression. So you don't have these problems. This was an interesting image taken from Weller et al. There was quite a few scientists involved, and it was a really nice study because they started looking at, we've been talking a lot about, excess pressure on the navicular bone from increased linear forces, from long toes, and et cetera, and how that DDFT itself is suffering with lesions and soft tissue injury because it's constantly in friction, and it wears away that navicular bursa, and then it remodels the navicular bone. So she started looking at these things, and they found a correlation. And in a nutshell, to summarize, they found that a bone, giving all things being equal, if you had two bones side by side, no other pathology, just looking at the two coffin bones. Basically, that coffin bone that has a little more bone mass to it, we call it the bone angle. If that coffin bone, two being equal, one is more concave on its solar ventral surface. It just has more natural concave line to it. The way the DDFT inserts into that coffin bone, that angle is slightly different compared to if you had a more acute angle. In other words, if your coffin bone was flatter, it had less concavity. The way that tendon would run around that fulcrum of the navicular bone and insert into the bottom of that P3, it would be a lesser, smaller angle, lesser than 90 degrees going in that direction. And what they found was the smaller the angle, the more acute the angle, the more trauma, the more pressure was being placed into that navicular bone and within that region, it would be more predisposed to navicular disease or navicular syndrome. And while that is brilliant, we can't actually measure that on an x-ray. All we can see is the coffin wing, which is your palmar angle. But here's the big take-home aha moment that I got out of that study was, regardless, Mother Nature gives you what it gives you, concave or not so concave solar surface. However, if you have a broken bony column, that far outweighs that small variance in the coffin bones. Because once your bony column breaks back, what happens to your palmar angle? It drops. And if it drops, what happens to that angle of insertion of the navicular bone, it becomes acute. In other words, it becomes a smaller angle, which we now know predisposes the horse to navicular syndrome. So it was a wonderful moment to consider how important bony column alignment really is in the bigger picture.
One of the most difficult things that we work with or run into is when this navicular bone with the deep flexor tendon running across its flexor surface, if you start getting some breaking apart of the deep flexor from a really broken back pastern axis or any other reason, and you get some lesions in the cartilage on the navicular bone, then you're going to start running the possibility and even probability of having a lot of adhesions of the deep flexor tendon to the navicular bone. These are a nightmare to work with. The horse has to be kept very carefully shod. It takes a long time to rehabilitate these horses, and some of them never rehabilitate. We just don't know enough about it. They are going in there and trimming those away on some of these horses and getting good results surgically. But the aftercare of that surgery is really specific. And I'm not sure that they've even got it nailed fully down what it is, because the surgeons are not farriers. And they do get more money if the horse comes back and has it done two or three times. So there is that. But you would have a tough rehab time with that. The only way to monitor it is with MRI, so that becomes pretty pricey just to monitor this thing.
And this is actually a snapshot when you are under mid-stance, full load. And you can see on the far right, if you follow the tendon, deep digital tendon, which is purplish, coated in color, that's not really its true color. You'll see, first of all, you see that red line along the distal third of the navicular bone, and that's where most of the pressure is found under mid-stance, and then, or the late phase of stance. And then you can see as you move upwards towards the right of the screen, you can see an actual space, a dark space between soft tissue and the tendon. So that occurs during the latter part of the stance, where you have the greatest amount of compression or the greatest amount of pull of the deep flexor. So you can see where, if you are going to start looking at measurements on x-rays and you want to monitor and repeatedly accurately monitor any improvements in your navicular bone angle, because as you align the bony column, the P2 and P3 are up here. Here's P2. Oh, you can't see my cursor, but you can assume where P2 and P3 are. Your navicular bone is attached to P3 via the impart. And then you have the T ligament on the other end. So whatever's happening to your bones as the bone alignment changes, it's taking the navicular bone with it. So as you have a drop in alignment, you're also having a drop in your bone angle for your navicular bone. So this is something you need to measure right around the red line area to see if you're improving over time with your actual navicular bone angle, because that's going to save some of that friction and compressive forces on the tendon.
What we're doing here, and again, Yogi sees a lot of these, I see a lot of these, we all do. And what we're looking, you can see that navicular bone angle is incredibly low. When you start getting a negative palmar angle, it drops dramatically. We're looking at a navicular angle, and this poor horse starts off at a less than 25 degrees. And we really like to hit 40 or close to it if we possibly can. There's not much space there. You can imagine if he goes into that full loaded stance, that navicular bone is liable to be parallel with the ground when he's done. It'd be interesting if you could ever take a snapshot in time and see if navicular bones have negative angles at full impact. But the trick is this one was rehabilitated rather nicely, because now we went from less than 25 degrees to above 35 degrees with just a minimal amount of work, really. It didn't take much to get that thing to turn around with a trim, no special shoe, a wedge. Everything's back in place. And again, you've got a pretty nice looking heel when you've got all that put up there. You see the heel bulb is rounded and not sort of bulging outward and backward anymore with the horse lining up. So it's the combination of getting that pastern axis back into position, and then the navicular bone gets dragged right up there with it.
So now we're going to have a look at some of the studies that have linked broken alignment to navicular syndrome. So if we look at Waguas-Pak 2010, he showed that the trabecular bone in the navicular bone suggested that the primary force acting on it was from the DDFT. And the amount of compressive force on the navicular bone was dependent on the conformation, which is obviously what we've been talking about. So more malaligned, more compression. It also suggested two theories for the pathogenesis of navicular syndrome, one being vascular changes and one being repetitive biomechanical forces, which goes with your earlier slide talking about the heel leverage, I think. It also stated that the treatment of navicular syndrome is to relieve the tension on the DDFT. But thinking preventatively, maybe this suggests the pathology would be less likely if the alignment was better from day one, which again, obviously is something we've been talking about. That study goes together with Thompson et al. And Ruff et al., which again stated that osseous changes to the navicular corresponded with greater compression. Images here show us some of the osseous changes. So we have enlarged invaginations, areas of lysis, cysts, esophagiophytes forming, and sclerosis. Would you guys say that every chronically malaligned horse you see has at least the beginnings of osseous changes?
Oh, yeah, I see quite a bit of those in horses that they're malaligned and they're sound, and yet the changes have already started. That means if you can see them, they've been there for quite a while too. So you had soft tissue inflammation in a horse that was appearing sound that takes minimally months and frequently years. So it is amazing the resiliency of a horse to be able to tolerate that.
You know, we forget about once you start seeing these bony changes, that tells you that there is quite a bit of significant damage in the soft tissue prior. And that means a lot of inflammation, and that means a lot of pain. So there's a lot of soft tissue causing pain in the caudal regions long before you start seeing bony changes.
Absolutely, and that brings us nicely onto this slide, actually, which are more recent studies showing the effects on the softer. As you can see, Ull et al. Found the compressive lesions of the navicular bone, so that's osseous, but also esophageal loss and disruption of collagen fibers, lesions of the deep digital flexor tendon, correlated with areas of increased tension, obviously. And then Osborne talks about the effects on the biotensegrity of the soft tissue structures, also echoing the earlier studies, talking about increased mechanical force on the tendon, on the navicular bone, the fibrocartilage, and the sesamoidal ligaments. So this also shows us, I guess, how important MRIs are in the process of assessing damage caused by malalignment, because these lesions to the soft tissue would not be visible on the x-rays. Do you often see horses that may appear structurally sound radiographically, but the MRI would obviously show a different story?
Oh yeah, it really will. It's a wonderful piece of equipment to have. It's unfortunate that it is such an expensive procedure to do. So this thing is seeing all sorts of little various lesions throughout the horse's leg that don't seem to mean anything. So we don't know if they're just somewhat developmental anomalies or just normal differentiations within a normal space, because we just don't have enough money to do the other limb to see if there's a mirror image of all that, so that okay, well, that is probably normal, so these other things that aren't found in the other limb are the abnormal ones. So it's a pretty interesting bag of worms when you start getting this newer technology and then running with it. They are doing some more normal horses, or at least horses they feel are younger, had not much been done with them, so that there's not going to be a lot of damage, to try to get some more normal variations that should be seen these days.
As I've definitely noticed when I get MRI sent to me, the reports, that there's always a section on findings that may not be clinically relevant, because obviously,
yeah,
like you say, they're going to see all sorts of things that may or may not be actually relevant to the issue. So now, as well as the damage to the internal structures of the hoof, poor alignment of the digit is going to affect all the way along the myofascial systems of the horse, something I spoke about with Martina. The principles of biotensegrity tell us that the position and orientation of any anatomical point along a myofascial line or kinetic chain will affect every other. So therefore, the position and the orientation of the hoof is going to affect the whole body along these myofascial lines. And we can clearly see here just how complex and interconnected everything is. So this malalignment of the hoof is going to possibly affect any of the anatomical points along these myofascial lines. And that's something we can clearly see from the studies that have linked poor bony alignment in the hinds with pathology all the way up the hind limb and into the trunk of the horse. And overstretching of these myofascial lines creates signals of pain in the horse, as I also discussed with Martina in the previous video cast. What studies have found in the hind is different from the pathologies that we've mentioned in the is that something you guys would agree with, that we see different pathologies in the hind, or do you still see the other changes as well?
Well, it's kind of yes on both accounts. We see a lot of similar changes, but then of course the hind limb has a bit different construction. But I do find the hind limb is also more ignored than the front.
Yeah.
Which is sad because it's helpful if I've got a horse with the front end lameness and they say, well, he's not lame behind. I said, we're going to align his pastern axis in the rear, whether you won't like it or not, you're going to pay for it. So because he needs that to help him. And the amazing part of it is it affects so much more of the horse than the front limbs do. It's these animals with horrible dispositions that buck, that are painful in the back, that get his SI joints injected 3 times a year. And then you straighten up his hind legs. And then one veterinarian actually got angry at me because the farrier and I went through and fixed all the hind feet in the barn. And her income from the barn dropped by 67%.
Absolutely. But that's definitely something I'm finding in my work is the amount of pain higher up in the horse that's being caused from negative plantar angles in particular.
Yeah, that previous slide reminded me of the fact I had read somewhere a while back about the rear end affecting the TMJ joint.
Yes. Yeah, and there's studies linking it to the hyoid and stuff as well.
Yeah. So the chiropractors, are working up at the front end, and it would be nice if they would call that farrier team to fix the back end. Of course, they wouldn't get as much chances to go back and readjust it, though.
There's also some interesting study work done on upward patellofixation in relation to broken backbone and column.
Yeah, I've repaired many horses and also many horses by not doing anything to the stifle except aligning the bony column in the rear. And the miniature horses in Shetland and little tiny ponies are notorious for locking their stifles unless you stand them up very nicely in the back and it goes away.
Wow. Now, talking about the myofascia, I mentioned with Martina, or she mentioned that it was full of all the nerve endings. Now, I know you guys have got something to talk on that.
Mm-hmm. Martina's presentation was, I'm going to say, it was delicious. I wanted to eat it all up. She really brought to light what so few of us understand about the complexities of fascia, and how it has a continuous feed loop to the brain. In addition to that, again, Bowker did some very good lab work on proprioceptors, and he went in there. Most of us know about frog proprioception, but there's so much more to it involved. There's so many mechanoreceptors in the foot. And basically he talked about some of them are related to pressure sensitivity, some is related to touch, some is deep tissue pressure. And basically what he said, during the different stances of the phase, you can see all these color codes that he's plugged in there. You've got different types of receptors that are engaging at different types during the stance relating to touch, feel, sensory, pressure. And altogether, this is giving a continuous feedback loop to the brain so that the brain understands not only where the foot is in spatial time, also understands pain when pressure is applied, which is very interesting. So when we come back to looking at these horses that have a long-term broken bony column, long-term, generally, they have a breakdown in the caudal structures. They tend to have thrushy frogs. They have poor digital cushion quality. Often the thrush is also developing internally, and it's actually working its way in through to the digital cushion tissue. So you have a lot of pain receptors going on there. So all of a sudden, when you start to load the back end of the foot, it can't handle it. And these proprioceptors are kicking in big time. You know, I've learned the hard way where I've trimmed up a foot meticulously. And I watched that foot, and that horse should walk off so much happier, and that horse walks off toe first. Why? Because the caudal structures were not prepared to take on that excessive load, because we had too much degradation of the tissues. So we had to take a step back, fix the tissues, and then move forward again with no problems. So these are all these adjunct things to think about, because it's so hard to talk about bony column alignment without wanting to go to how do we fix that, how do we support the rest of the foot, and things to consider so that it goes well for you. So we don't want bony column alignment to have a current situation out there in the field today is many of us say we actually have to take our time to do it. It's not good for the horse to go slowly. And in fact, it's the soft tissue and pain receptors we're dealing with that is slowing down that corrective process. So we have to be a little bit smart or smarter about how we're going to support that foot, how we're going to support the sore areas. Go in and use your hoof testers. Find out exactly where your sore areas are. See if you can be creative and find ways to unload the sore areas while maybe overloading some stronger areas temporarily, so that you can move forward with your bony column alignment, which is now going to set you into a situation where things will continually progress and you will stop or greatly reduce the pathology, which is a really prime concern, because the longer you wait, the more difficulty you're going to have dealing with progressive pathology.
We've talked about the importance of aligning the foot, so now we're going to kind of be a good idea to briefly discuss some options for creating alignment. Now, I don't want to go into too much depth for that for another day, but if we look at, these are some of the options that I use, but I know you guys have got a particular method that you wanted to talk to us about, and that was the roller shoe.
These have been very good for me. It has a lot of advantages. One of the thing that Dr. Redden has always put out there is that it's a self-adjusting shoe. The horse can kind of put himself into the situation that he likes at any one moment. Also, as he's healing, the shoe he may be rockered up on the toe a little bit more, and then he'll start coming down as things are the inflammation starting to cool out, and he'll start to put himself back into a normal position for him. So these are really, really good positions for that. Now, the trick to that is you need to put the belly in the right place. That is absolutely critical. If you put this thing too far forward, the horse is going to start leaning back into the rocker just because you've leveraged him into it. If you put it too far back, he'll wind up flipping up on his toe and landing on his toe as he's moving along, particularly if he's moving slowly. So you want to make sure you've got that balance. A lot of times just getting everything put together and then tacking it on with just 2 nails and putting the horse's foot down and letting him relax, we'll see if you've hit the right spot. But as long as you've got a good handle on where your COR is, you should be able to just put that thing right on and put it down, and the horse will sit there and smile at you and lick his lips and say thanks and undo the other foot. Again, with the landing with these is wonderful, because with that airspace under the heel, now when you're landing and it's in the right position, you're going to get a really nice slide. And with that, you're going to greatly reduce the vibration of that impact of landing. So you're really helping the laminy out even in movement and on the landing phase as he comes into that stance phase of stride, as well as the enrollment. And then he's just gone. There's no toe in the way. He's got a wheel on the end of his leg.
Yeah.
There is a very small adjustment period. Sometimes it's a matter of 6 to 10 strides. Sometimes it's a day. But it's just like yourself. If you try those new roller running shoes for humans, it's the same kind of effect. You have to appreciate that proprioceptors are going to kick in. And so you will adjust, but you adjust very, very quickly.
And Sylvia, I know you've now got quite a nice little example of how alignment can increase the longevity of your horse's working life.
I think, you know, we're close to wrapping up our session, and I thought it would give a lot of folks out there hope. You know, this is one of my beloved, rest in peace, Welsh Cobb Standardbred, big boy. And I was young in those days, and in his young teens, he was well used. He was a hunter, he was a jumper, he was an eventer. He worked 7 days a week, and for most of his life. But he broke down as a teenager, and locally we had 4 vet assessments, and the news was not good. The prognosis was navicular syndrome. He was grade 2 to grade 3 lame, and the idea was, let's butte him, see if we could get anything more comfortable, and if not, give him a year, we'll put him down. So he didn't progress, and this is way back in the day when I first collaborated with Dr. Myers on my own horse, and found out, you know, it was the best partnership I ever could have had in my life. And so thank you, Toki, so much.
Well, you're certainly welcome. You've made it worthwhile through the years.
Thank you. You know, this proves to you out there, you can have a great change around even when you have a bad prognosis. And if you look at the actual x-rays, they don't lie. So here his cannon bone is vertical, so you can truly assess his bony column alignment. And for the most part, he's very, very close. So he's in that safe range, right, that you're trying to attain all the time. And because of that, he went back into full work till he was 25. Not a day lame, not a day, with the same kind of grueling schedule. And you can see, yes, he has some side bone, but when you look at the amount of work this animal did, that's very minimal. And he has very little remodeling of his bone. This roller came in nicely. It worked very well for him. And I did retire him at 25, not because I needed to, but he was such a hot horse that I couldn't handle him anymore. So
yeah, I like riding a rocket.
Drill hacks.
I rode him once.
Yeah, it only took once, huh?
Yeah, I didn't let him get any head of steam under him.
He did die at age 31. He did develop PPID very badly. We had him medicated, but he started to have problems. So rather than let him suffer, and he had a full life, and he told me it was time, and we let him go with dignity. But this is a beautiful example of what you can do. You can turn these horses around, and you can have very productive working in heavy load disciplines, and for a long time if you keep it up.
So to close, malalignment may well be common, but from everything we've said, it obviously strongly predisposes to pathology. Now, as we've just seen in that case just before, that lovely case, if we set up our horses with an optimal base, we will inevitably increase the longevity of their working lives. Now, Toki, I know you've got a wonderful statement to close our videocast with.
Well, we were always talking about everyone wants to seem to drift towards the fact that we see this very often, and yes, we do, but we see a lot of things very often that people get thrown in jail for too. And however, just on the physics of it, here would be a statement I would make is no one builds a crooked lever arm when you have need of a straight force direction.